Hello, good morning. This video is 120. It is for BSc Part 2, Organic Chemistry, Paper 2, Unit 1, IR Spectroscopy. In today's lecture, we will discuss about factors affecting on IR absorption bands. Strength of bond. If bond is strong, then its frequency will be higher. For example, in ethanol, this OH bond is strong, so its frequency is observed at 3640 inverse centimeter. Whereas in acetic acid, OH bond is weaker due to the resonance effect, so its frequency will be lower, 3500 inverse centimeter. In trichloroacetic acid, OH bond is weaker due to minus effect of chlorine. So it is again lower frequency of absorption. Therefore, strong bonds have greater stretching frequencies. Electronegativity of bonded atoms. OH, it is depend upon the electronegativity of atoms. Oxygen is more electronegative than nitrogen, than carbon. So its OH frequency is also higher, 3600 inverse centimeter. NH 3500 to 3300 inverse centimeter. Carbon hydrogen 3000 to 2850 inverse centimeter. Atoms increases with increase in electronegativity of constituent atoms. The electronegativity of oxygen is higher than nitrogen than carbon, consequently. So their frequencies are also depend upon the electronegativity of atom. Second factor, atomic weight of bonded atoms. The greater the atomic weight of involved atoms, lower is the stretching frequencies. Thus, OH, its molecular weight of lower compared to OD, oxygen and deuterium. So, molecular weight is if lower, then its frequency is higher. If molecular weight is higher, then its frequency is lower. Hydrogen bonding. Hydrogen bonding generally lowers the stretching frequencies but increases the bending frequencies. See here, uh, this alcohol, if it is hydrogen bonded, if it is dissolved in water molecule, then its frequency is lower, 3500. Where in pure alcohol, absolute alcohol, its frequency is higher. But here, bending frequency is here lower, and in this dilute one, it is higher. Conjugation. The stretching frequency of multiple bonds is decreased due to the conjugations as it increases the bond length by resonance. This isolated bond and this is conjugated bond. So conjugated bond, double bond, it's having lower frequency, whereas isolated having higher frequency. Isolated and conjugated. This is the overall frequency range data. This 600 to 1400 frequency range is known as fingerprint region, whereas this 1600 to 4000 range is known as functional group region. Characteristic absorption of various functions. Characteristic absorption bands, which are helpful in the identification of fundamental groups in different class of compounds, are given below. Alpha OH stretching vibrations, and it is in the range of 3650 to 3000. CO range is stretching is in between 1260 to 1000. This is little bit sharp if it is in vapor phase. If it is concentrate, then it is lightly broadband. So it depends upon the hydrogen bonding. Acetic acid in vapor phase, it is slightly sharper. In liquid phase, it is broad. See this molecule, orthohydroxyacetophenone. In this hydrogen bonding, it is intramolecular hydrogen bonding. Here there is no effect of dilution and it is observed at 3040 %. In parahydroxyacetophenone, intermolecular hydrogen bonding, it having higher value on dilution. Aldehyde, ketones, carboxylic acids, amides, and esters. CO stretching vibration band is observed in the result. The exit position of this band varies in different classes of compounds. Following factors are responsible. Conjugation. Here in acetone, its value is higher compared to this molecule and compared to acetophenone of carboxylic acids. OH frequency in carboxylic acid, it is slightly lower because it due to the intermolecular hydrogen bonding, and the CO is little bit higher. Intramolecular hydrogen bonding further lowers the absorption frequencies. In orthosalicylic acid, see here, intramolecular, due to the intramolecular hydrogen bonding, OH frequency rate is lower. Esters, in esters, CO stretching 1750. In amides, it is a little bit lower. Amino peak is in the range of 3350. It is a broad doublet. Mesomeric effect. Due to the plus M effect of methoxy group, this carbonyl absorption peak is lower, whereas in nitro, when nitro group is present, it is an electron withdrawing or minus M effect. Its value, CO value, CO absorption value will be increases 1710. Inductive effect. Inductive effect is also playing a very important role in the absorption frequency. See here in acetophenone, its value is higher, whereas in this molecule, due to the amino electron donating group, its value is low. If minus I is higher than plus M, then CO value will be increases. So these are the examples of mesomeric effect or inductive effect. Ring strain. Ring strain is also playing important role in frequency of IR. Here, there is no ring, but here the ring strain in this hexanone, cyclohexanone, this value is low. In cyclopentanone, there is more strain, so it is higher. In cyclobutanone, it is again higher ring strain, its value is also high. Acid halides. In acid halides, carbonyl is due to the presence of chlorine halogen, its value is higher. Here, in due to the conjugation, its value will be lower. CO stretching frequency value will be lower. Acid anhydrides. In acid anhydrides, asymmetrical and symmetrical CO stretching absorption bands near 1818 and 1750 is amines. Two absorption bands near 3500. It is vacuum vibrations, asymmetric, symmetric. So asymmetric is observed at 3500 due to the asymmetric, whereas 3400 is due to the symmetric vibration. Bending, scissoring vibrations are about 1650 to 1580. Single absorption band near this value is observed. In aromatic amines, its value will be lower. Tertiary amine do not give any absorption band in this region. Ethers, aliphatic ethers, stretching asymmetric will be observed. These are the values. So thank you very much for today's lecture.